Hello guys, and welcome to Math 101. For today's lesson, I will discuss the factoring and the methods on it. Now please pay attention as my favorite AI teacher Mark explains the essence of factoring and some examples that will help us understand what is factoring. So let's start.
And now we are here in factor expressions in the world of mathematics. Now, what is factoring? Finding the variables is the method of factoring. It's the equivalent of splitting an expression into a series of simpler expressions. Let's take this example. Factor 2y plus 6. Both 2y and 6 have a common factor of 2. So we can factor the whole expression into 2y plus 6 equals 2 open parenthesis y plus 3 and close. And now, there are two types of factors that will help us identify each expression. First is the composite factor. A composite number or factor is a natural number that can be split into multiples of 1 and itself. A composite number, on the other hand, is a positive integer with more than two variables. Since they are composed of other numbers, the numbers 4, 6, 8, 9, 10, 12, and so on are composite numbers. In the example below, 36, 12, and 4 can be split into two variables into multiples of other numbers. The second is the prime factor. A prime number is a natural number that is greater than 1 and can only be divided by itself and 1. For example, is 19 a prime number? Yes. The only factors of 19 are 1 and 19, so 19 is a prime number. That is, 19 is divisible by only 1 and 19, so it is prime. Now, there are 15 problem examples that will be related to factoring. First, let's have this d squared minus 1. The first step is to apply the difference of two squares formula, which is t squared minus 1 square, which will give the answer of t plus 1 and t minus 1. Proceed to number 2, we have x squared minus 49. Same in the number 1. Apply the difference of two squares formula, which is x squared minus 49 squared, which will give us the answer of x plus 7 and x minus 7. For number 3, we have 16x square y squared minus 81. First, apply the exponent rule that will give us the answer of 4xy squared minus 9 squared. 16 and 81 can be multiplied through numbers 4 and 9. Then, apply the difference of two squares formula, and now it will become open parenthesis 4xy squared close parenthesis and squared minus 9 squared and will give us 4xy plus 9 and 4xy minus 9. In number 4, we have 7ab raised to 4 minus 7ac squared. Let's factor out the common term, which is 7a. Then, factor b fourth power minus c squared, and it will give us the answer of b squared minus cb squared plus c. The result will be 7ab squared minus c, then b squared plus c and close. And now for number 5, a squared b squared minus 1/4 c squared. The step is to simplify only the a squared b squared minus 1, which will give us the answer ab plus 1 a b minus 1, close parentheses. Proceed to number 6, 9m raised to 4 minus 16 over 25 and 6. The same process in number 5, only the numerator, which is 9m, raises to 4 minus 16. That will give us 3m squared plus 4 and 3m squared minus 4 over 25 n raised to 6. In number 7, we have x raised to 10 minus y raised to 4. We use the difference of two squares formula and distributed by polynomial expression. That is why we came to an answer of x fifth power plus y squared and x fifth power minus y squared. For problem number 8, we factor out the common term, so we have x fifth power and open parenthesis x squared minus 1 and close. After that, we must factor the x squared minus 1, and we have x plus 1 and x minus 1. Now we can come up to an answer of x fifth power, x plus 1 and x minus 1, close parenthesis. For number 9, we have x fourth power minus 1. The first step is to apply exponent rules, having an answer of open parenthesis x squared close parenthesis and squared minus 1 squared. After that, we have to apply the difference of two squares formula to distribute, having the answer of x squared plus 1 and x squared minus 1. After that, factor the x squared minus 1. And now we have the final answer of x squared plus 1, x plus 1 and x minus 1 close. Let's proceed to number 10. In this problem, we can conclude that this is a prime expression since the biggest common factor is the factor that all have in common. Also, when no further factoring is necessary, an expression is said to be fully factored. Proceed to 11. We have 64y squared minus 1. The first step is to apply the exponent rule, which will give us the answer of parenthesis 8y close parenthesis squared minus 1. And second is the difference of two squares formula to factor, which will give us the answer of 8y plus 1 and 8y minus 1. For number 12, we have m squared minus 2m plus 1. We need two numbers that add together to get minus 2. Now, multiply together to get 1 to get the answer of m plus 1 and m minus 1. Next, let's proceed to 13. We can say that it is prime because there is no way to find two integers b and c such that their product is 6 and their sum is also 36. So, we cannot factor into linear terms. Proceed to 14. Since the b is considered as 0, we cannot factor it, which makes it a prime polynomial. And now for number 15, we have 3a raised to 6 plus 6a raised to 3 plus 3. So first step, factor common term, which is the number 3. After that, we need to factor the polynomial, which is a raised to 6 plus 6a raised to 3 plus 3. So we come up to an answer of 3 parentheses a plus 1 squared and a squared minus a plus 1 squared. Or, you come up an answer of 3 parentheses a plus 1 a squared minus a plus 1 and another a plus 1 and a squared minus a plus 1. So that concludes our factoring tutorial. Thank you so much, but before that, there is a quote. "The beauty of mathematics only shows itself to more patient followers," by Mariam Mirzakhani.
And there you have it, guys. Thank you for watching till the end, and I hope that you all learned something about factoring. So thank you guys and goodbye.